In example 4-9, we are required to look at how the gas, when it expands adiabatically from, in this case, a pressure of 700 kilonewtons per meter squared and a volume of 0.015 meter cube or cubic meters to a final pressure of 140 kilonewtons per meter squared. We are asked to calculate the final volume, the work done of the gas. We are also asked to calculate the internal energy of the gas. We are given the specific heat at constant pressure and the specific heat at constant volume. So before we can get our answers, let's get the parameters that we require for adiabatic process. Firstly, we need to see how we calculate gamma. So gamma is the ratio of specific heats, Cp over Cv. Now this works out to 1.046 divided by 0.752, giving us an answer of 1.391. After that, we need to calculate R, the gas constant, which is equal to Cp minus Cv. Here again, if we put in the figures of 1.046, okay, 1.046 minus, in this case, 0.752, we will get the number of 0.294. Okay, we need to know the units. In this case, it is kilojoules per kilogram K, same as Cv and Cp. Okay, having got that, let's now get to solving the question. P1, we are told, is equal to 7 bar. P2 is equal to 1.4 bar. V1 is equal to 0.015 cubic meters, and V2 we have to find. So using the adiabatic rule, what is the adiabatic rule? For pressure change and volume, P1 to the power of gamma equals P2 V2 to the power of gamma. In this case, we know all the terms, P1, we know P2, we know V1, we have to calculate V2. So we continue with our solution, and what we have now is V2. We bring all the terms that we know on the right volume, and the pressure terms we know on the right, and the volume V2 is required. So let's recast our equation as follows. V2 over 0.015 to the power of 1.391 is equal to 7 over 1.4. This gives us a volume of V2 equal to 0.0477 cubic meters. Now this will be our first answer. We now proceed to calculate the work done. The work done, W, we make use of the formula work done is equal to P1 V1 minus P2 V2 over gamma minus 1. Now this is a standard formula for calculating the work done for adiabatic process, which we can get from our formula sheet. So what now we do is we plug in the values, and I'll leave it to you to do the calculations. We will get an answer of 9.77 kilojoules. And finally, the answer for heat transfer is equal to 0, because remember, this is an adiabatic process. And the last answer is the change of internal energy is equal to Q minus W, but Q is 0, so that is equal to minus W, which works out quite nicely. We just copy the value 9.77 and put a negative sign. And that's our final answer.